In this lesson, we're learning about properties of parallel lines. The objective is to prove theorems about parallel lines and to use properties of parallel lines to find angle measures. The first postulate in this lesson is the corresponding angles postulate. If a transversal intersects two parallel lines, then corresponding angles are going to be congruent. Note that this is only true if the two lines that the transversal intersects are parallel, and that's indicated by the parallel markings on lines L and M in the diagram. So in this diagram, look at all of your pairs of corresponding angles. Angle 2 and angle 6 are corresponding, so they're going to be congruent. Angle 3 is corresponding to angle 7, so they're going to be congruent. Angle 1 is congruent to angle 5 because they're corresponding, and angle 4 is going to be congruent to angle 8 because they are corresponding. Now you can use this corresponding angles postulate to prove the other angle relationships below. For the alternate interior angles theorem, if a transversal intersects two parallel lines, then alternate interior angles are going to be congruent. Same diagram, we have lines L and M parallel to each other. So let's identify the alternate interior angles that are going to be congruent. Angle 3 and angle 5 are alternate interiors because they're opposite sides of the transversal, and they're on the interior of lines L and M. The other pair of alternate interior angles are angle 4 and angle 6. Once again, opposite sides of the transversal and interior to lines L and M. The next theorem is the same side interior angles theorem, and it states that if a transversal intersects two parallel lines, then same side interior angles are supplementary. So in the diagram, lines L and M are parallel. So look at the transversal and identify the same side interior angles. On the right side of the transversal and on the interior of lines L and M, we have angle 3 and 6. So the measure of angle 3 plus the measure of angle 6, since they're supplementary, it's going to be 180 degrees. And on the left side of the transversal, we have the measure of angle 4 plus the measure of angle 5 are supplementary, so they're going to be 180. The last theorem is the alternate exterior angles theorem, and it states that if a transversal intersects two parallel lines, then alternate exterior angles are congruent. So the alternate exterior angles in the diagram, lines L and M are parallel, so the transversal intersects those two lines, and lined angle 2 is going to be congruent to angle 8 because they are alternate exterior angles, and angle 1 is going to be congruent to angle 7 because they are alternate exterior angles. In problem 1, you're identifying congruent angles, and it asks which angles have a measure of 130. So look at the diagram and the angle that's marked as a measure of 130. And look and see which angles are congruent to that angle. So according to the postulates and theorems that we just had over on the left side of your page, corresponding angles are going to be congruent. So the angle that's corresponding to the 130 degree angle is angle 5. So that means that the measure of angle 5 is going to be 130. Because they're corresponding angles. And then the measure of angle 4 is going to be 130 because they're vertical angles. So don't forget, we can still use that vertical angle relationship from the last chapter. And finally, the measure of angle 2, is going to be 130 because it is an alternate interior angle to the 130. It's also vertical to the angle 5, so that's another relationship to know that that is also 130 angle, the 130 degree angle. In problem 2, we're proving an angle relationship. We're given that angle A is parallel to angle B. I'm sorry, line B. Line A is parallel to line B. And we need to prove that angle 1 and angle 3 are supplementary. So let's do a 2-column proof and put our statements on the left and the reasons on the right. So the first statement, we'll start with what's given. A is parallel to B. And that is given. Second statement, since we know that A and B are parallel, we can make the statement that angle 1 is congruent to angle 2 because they are alternate exterior angles. So that's the alternate exterior angle theorem. Third statement is from the diagram. We can see that angle 2 and angle 3 are a linear pair, so that means that they are going to be supplementary. So angle 3 and angle 2 are supplementary. And that's because of the linear pair postulate that we can make that statement. And so finally, we can make the statement that we want to prove, and that is that angle 1 and angle 3 are supplementary. Because of the congruent supplements theorem. Problem 3, we're finding the measures of angles, and we need to find the measures of angles 8 and 4 and explain, which just means we need to give a postulate or a theorem that justifies the statement that we're making for the measurement of angles 8 and 4. So in the diagram, if you look at your parallel markings, angle A is parallel to angle B because of the matching double parallel markings on the lines. So since those are parallel, we know that angle 8 and the angle that's marked 115 degrees, those are same side interior angles. So by the same side interior angles theorem, we know that those are supplementary. They got to add to be 180. So since A is parallel to B, so the measure of angle 8 plus 115 has to equal 180. And that's because of the same side interior angles. So if you subtract 115 from both sides, the measure of angle 8 is going to be 65. Now the other angles that we need to look at are, we need to find the measure of angle 4. So let's look at the other two lines. The other two lines are M and N, and they have a matching parallel marking. That's a single parallel marking up on the top of those lines. So M and N, M is parallel to N. So that means that the measure of angle 4 has got to be 115 degrees, because angle 4 is corresponding to the angle that's marked with 115 degrees. So that's the corresponding angles postulate. In problem 4, finding an angle measure, we have to find the value of y. So let's look at the markings on the diagram. Look for parallel markings. So on this one we have a couple of parallel markings on these two lines. So those are the two lines that are parallel, so that means you need to identify transversals for that line that would be useful in finding the measure of the line of the angle that's angle y. So if we look at this line as a transversal, it's a line that intersects both of those parallel lines at two distinct points. Then the angles that are marked, the angle that's marked 50, and this entire angle that is y plus 60, both of those angles are same side interior angles. They're on the same side of the transversal, which is below the transversal in this case, and they are both interior to the two parallel lines that are marked parallel. So they're same side interior angles. So that means that their sum has to be 180 because they're supplementary. So let's look at how we set this up. So we have the measure of angle y. Measure angle y plus 60. That's one angle together, plus the other angle that's supplementary to that is 50. That equals 180. And that's because of the same side interior angles theorem. So now we can solve this. You have the measure of angle y plus 110 is equal to 180. Subtract the 110 from both sides. Measure of angle y is equal to 70.